Welcome to EDU World Space.
All right, so here we have a problem on Human Biomechanics. The fastest serve in tennis was done by Big Bill Tilden in 1931, as the problem states. That's measured at 73.14 meters per second. We know the mass of the tennis ball is 57 grams. It's in contact with tennis racket for 30 milliseconds. The ball is starting from rest. We're assuming a constant acceleration. That's going to be our cue to use kinematics. And we want to know what force did Bill's racket exert on the tennis ball, and with the assumption that it was all horizontal force. Then we're going to do a free body diagram on that for part B. So starting off with what we know the velocity original is 0 right as the ball contacts it and brings it to a stop before accelerating. The velocity final given was 73.14 meters per second, mass 57 grams. Time, we're going to go ahead and convert that to seconds because milliseconds won't be particularly helpful, 0.030 seconds. We're looking for the force, and we will need acceleration to get there. So because a delta x for displacement is what we're missing, the only kinematics equation we can use here is velocity equals velocity original plus acceleration times time. We can go ahead and start plugging in. We know the velocity is 73.14, and that's meters per second. And we know we're going to have to divide by time. This is going to be 0. Divide by time will give us acceleration, 0.030 seconds equals acceleration. We should get meters per second squared. We have seconds on the bottom with the seconds again. That's going to give us second squared, meters per second squared. And what value do we actually get there? 73.14 divided by 0.030. That's going to give us an acceleration of 2,438 meters per second squared. All right, so we have an acceleration here, and now we want to get a force. So F equals ma. We have both mass and acceleration, so this is going to be an easy calculation. We have 57 grams. If we want newtons, which I would prefer here, you're going to want to go with 0.057 kilograms times your 2,438 meters per second squared. Now we have kilogram meters per second squared. That is going to be a newton. That value ends up being 139 newtons. But we're not done yet. We need that free body diagram. So the second, as it's exiting, we have our ball. When it was held by the racket, it had a normal force keeping it from falling. But here, we just have the force acting on it as the racket hits it, that 139 newtons that's causing acceleration. And also, to a lesser degree, we have weight here, which would also be mass times gravity. And that's the forces acting on the ball. Of course, there's going to be a little bit of wind resistance, acceleration caused by the rotation of the Earth, stuff that's going to be negligible in a problem like this. And that's it.